Hi everyone, welcome to this tutorial. Today we will be learning closure and lexical scoping. Before learning closure, we have to understand lexical scoping. So let's understand first what lexical scoping is, and by end of this video, the closure and the lexical scoping will be very easy topic for you to understand and remember. Okay, so let's understand what is lexical scoping. So lexical scoping in JavaScript is a phenomenon or a design pattern where the inner part of the code has access to the outer part, but the outer part of the code doesn't have access the data of the inner part. Let's have example for this situation. We have a function test. There is a if condition starts here, ends here, another if condition start here, end here. The function start here, end here. And for your knowledge, this curly brace, valid curly brace, and valid ending curly brace is a one scope. Sorry, is a one block. Code block, right? This is a valid code block, this is a valid code block, and this is another valid code block. And in the block, we have two types of scoping, function scoping and block scoping, that we will learn in the next video. But today let's understand what is scope first. So scope is nothing but in what region you can see, or in what region something is accessible. For example, you are standing here. This is 1 kilometer range, this is a 5 kilometer, this is 0 kilometer, and this is a 8 kilometer. This is a scale, right? And you can see you have a telescope where by which you can see from 1 to 5. This region you can see. You cannot see before 1, you cannot see after 5. So your scope will be what? The scope of this telescope is what? Scope range of this telescope is 1 to 5. That's all. Everything between 1 to 5 is accessible. Everything between 1 to 5 is visible to you. Same way, JavaScript uses scope, and the kind of scope JavaScript uses is called lexical scope. Why this is called lexical scope, that I'll clear here in this video. So if you see, I have given three color. Green color is from here to here, this region. Blue color is from any code if you write between this, and yellow is between this region. Now the lexical scoping in JavaScript, what is very simple. Anything which is outside is accessible from inside, but whatever is inside is not accessible outside. Okay, again I'm repeating, whatever is outside. What I mean by outside, outside means this is a one scope, this is another scope, this is another scope. This is a parent scope, child scope, second child scope, right? This is under this and this is under this. So this is the outside region and this is the inside region respect to this, right? So anything outside is accessible inside, but anything inside is not accessible outside. If you understand this phenomenon, you are done with the lexical scoping. Lexical scoping sounds fancy, the word, but in the reality it's that much simple if you understand correctly. Okay, anything outside we can, so suppose there is a variable a, you can console.log variable a, sorry, console.log a, you can access that. Okay, but whatever present here you cannot access here. Again, there is exception regarding hoisting, let const var. We will come to that later in the later video. I hope the lexical scoping is clear. So in the yellow region, you can access the blue and green region data. Data means the variable, whatever you have. In the blue region, you will have access to the green but not yellow. In the green region, you will have access to the outer of this functions data but not this. I hope you are clear with this. Let's have a code example of closure. But let's first understand what is closure is, right? If you understood the lexical scoping, closure will be easier for you. So if you go to the Google and any other forum, you search for the closure definition, or if you want to learn the closure, the definition will come out like creating private variable, or even though the outer function is executed, the inner function has the access. But none of this definition clears your doubt regarding closure. So if you write the definition closure, first of all, what does this sound, closure? Closure means basically It's a JavaScript phenomenon where JavaScript creates a container, invisible wrapper, where you have a function, particular function. Also, with that, you have a lexical scope data of that function. Now, for example, what is the lexical scope data? If I declare a variable a, here I declare variable b, and if in this yellow region, what is the lexical scope data of this yellow region? I know the lexical scope is, I need to go like this, right? Outside. So lexical scope data will be a and b, right? The same way, closure is what? Closure of a particular function is basically and for the clarity of the understanding, closure as of now you can understand we will only do in case of functions. Okay, so here so any function with its lexical scope data, it binds together. Okay, or the inner any function always have reference to its lexical scope data at point of creation. So when we create this function, for this code example, you have a outer function create counter, inner function increment. The increment one will always have what is the lexical scope is of this increment. This is the outside region of the increment. This is the lexical scope, and also this is the outside of the create counter, also lexical scope. So what is the whatever data you have, you can see here. This increment will always remember. This will be always known to increment. It won't. The increment function will not forget this data. Okay, how their closure comes into the picture. So if you see this diagram, I have done a diagram for you. This is the this is the increment function where we can see a count 0 and we have an invisible bubble or container or wrapper. Where it comes from, let's see the code. This is a code. If you see this outer function, after that outer function there is a let count 0. There is another inner function. Inner function is doing something. We will come to that later what is doing. And at the end of this, the inner function, the outer function basically returning increment, right? Increment means this function. So the outer function basically returning this inner function at the end of the of this function, right? So whenever we call the create counter, what does it return? It returns this function body. But when this returns this function body, so if you see this line, const counter equal to create counter, we have called this the outer function. Now the outer function returns what? The outer function returns the inner function. But that's not the only case. Yeah, create counter returns this inner function and we have stored that inner function in the counter variable. But we are not storing only that function. We are storing this function plus the lexical scope data. So eventually what we are storing there, we are storing this. Basically we are storing this, the increment function, and we know that by closure what this increment function do, it glues or bind the lexical scope data with it. Wherever this increment function will go, it will carry forward or it will take the reference of this. The count always will, it will have, though we cannot see in the code, though we cannot see in the under the hood, but under the hood it works like that. This function at the outer place always have this variable so that this can remember, right? This is called closure, when the inner function can remember its lexical scope data at any point of time, right? So if you see what we are doing here, we are doing create counter we are calling. Create counter is returning what? Increment. Increment is what? Increment is this inner function. So basically we are storing the inner function under the count in the counter variable. So by the previous diagram, you can also imagine or visualize the increment function is stored here with count 0. Now what happens? So we know counter has stored function increment. When we call here when we call the counter here, what we call this eventually this function, and this function is doing what? This is doing count plus plus and printing the count. Now let's imagine how this function looks like. Function increment. by closure diagram you can see there was a count 0, right? Now when we call here, what we do? We do the count plus plus and console.log count. What we do here? Count plus plus 0 plus 1. We got count. We have updated the 1 count with 1 and we are printing. So that's why we got 1. In the second case, what we do? We again call the counter, means this one. So by this code, what you can see, we have taken the copy. We have created the copy of this function only one time. This one. This is the copy of the function, the closure, right? And we have at this line we have increment the count by 1. Now when we do the second time this function call, we do the same step again, count plus plus and console.log count. Now what is the count now? 1. 1 plus 1, what we do? We update it to 2, right? We update it to 2 and it logs 2. Again when we do count plus plus like this one, when we call the counter, we are eventually calling this counter function, and this counter function has the same function body. It doesn't change like that, right? The function body is same, but the closure variable has changed to 2. Now if you do counter plus plus 2 plus 1 3 and it prints 3. This is the closure. This is how closure works. And if you explain this thing to interviewer like that, the interviewer will be impressed by you. And what is the real-time use case of the closure? Let's note it down. So the real-time use case of the closure is, you can say to the interviewer, use state hook, use memo, use callback, caching, creating private variables, memoizing. So I hope closure and lexical scoping concept is clear to you and you can explain anyone after that this video. Please subscribe my channel. Also please like this video, share this video. I'll update more videos on front-end interviews like DSA, polyfills, system design now. Thanks for watching. Thank you.